Hello, my name is Muhammad Abbas Khan, and I am currently in 11th grade at Harmony Science Academy, Carrollton. So today, my PBL project for physics is the Euler's disk, which is named after Leonard Euler, who studied it in the 18th century. So materials we need is a chrome-plated steel disc that is a half-inch thick and 3 inches wide, a concave mirror base that provides a dramatic setting for the disc, and magnets to enhance the visual presentation. So now I will show you how it works. So basically, many of you might see it spinning, but it is actually spinning and rolling, a term called spoiling. So topics we see in the Euler disk is potential and kinetic energy, gravity, friction, and etc. So these are low friction materials which provide it to spoil even more because of the small amount of energy lost due to friction it produces, surprising amount of motion. So, however, in relation to conservation of momentum, the disk contains potential and kinetic energy. So, potential energy is given when it is placed upright on its side, and kinetic energy is shown when it is spun. But since we're in a world where friction and vibration, it would stop. So, we're going to see when it stops eventually. That's it. Now I'll talk about my ELA or English Language Arts component of my physics PBL, the Euler disk. So what I chose was the narrative essay because I felt like telling a personal tale would actually benefit other students and me much more to see how I progress my thoughts through the experience of having this PBL project. So this is my project called the Euler's Disk, and I asked my physics teacher to give me the Euler's Disk so I can experiment and do my PBL project on it. So when I first saw it, it seemed really interesting to me as it was a chrome steel disc and with a concave mirror, and it was really cool when I tested it out. So I wanted to choose this. So I actually chose it, and I started examining the physics behind it and all of the things that are the components of the Euler's disk, and I found that it was really interesting because it not only spins but it actually rolls too, which is a term called spoiling. And I studied it extensively, and it showed like so many types of physical traits, such as conservation of energy, as it is standing on its side upright right now. It's showing potential energy, but when it starts moving, it shows kinetic energy. So that's my English ELA component. So this is my social studies or SS component of my PBL project. So basically, I did historical connections. So in my historical connections, I talked about Leonard Euler, who studied the Euler's disk and its physical traits in the 18th century. So when I discovered about Leonard Euler, I saw that he was one of the greatest mathematicians of all time, and even in the 18th century. He was born in Switzerland. He spent much of his time in Russia and Prussia, and he is the only mathematician who has two numbers in math named after him. So, which is the E constant, which is 2.7828, and the Euler-Mascheroni constant, or the gamma letter in the Greek alphabet, which equals to 0.57721, which is also referred to the Euler's constant. Reading on literature about Euler, he was very interested in the maths and physics of spoiling, which is technically the word for spinning and rolling. Rigid bodies, hoops, and stuff like that. That's why it has this disc has the name Euler's disk. So he set up equations using Eulerian angles and Eulerian equations of motion. So yeah, people in the future ahead of Euler used much maths to figure out how it works. So they actually said that the toy might lose some of its energy by squeezing out the air between its rolling edges and the mirror's base. The equation of a perfect fluid, modified by various mathematicians in the future, is the work of Leonhard Euler. So yeah, that is my social studies component, and thank you for watching. I am a student of Harmony Science Academy Carrollton, and I'm in 11th grade. My name is Muhammad Khan, and thank you. Goodbye.